video, we're going to review the unit circle and we're going to look at the sine curve. So periodic phenomena such as tides or orbits need to be modelled by periodic functions, and the most frequently used are the sinusoidal functions. And you can see the form that these take and the way that we notate them in the IB. So we're going to take a look at our unit circle. Our unit circle obviously is a circle with radius 1, hence the name. We've already been talking about where we measure angles from, which was the positive x-axis, and how conventionally we're going to measure them taking the positive as the anti-clockwise direction. So let's take a little look at y cos theta is equal to x and sine theta is equal to y. And this is not going to take us very long. If we take a look at this triangle here, we can see that cos theta would be the adjacent side over the hypotenuse. And obviously if our hypotenuse is 1, we get that cos theta equals x. Similarly, sine theta is the opposite side to the angle y over 1, which of course simplifies to sine theta equals y. So we have a way of linking theta with the position we are as we move around the unit circle, and that's going to give us a function in terms for sine theta and a function for cos theta. We can also think of tan theta as well. Tan theta is the opposite, y, over the adjacent, and if we substitute what we've just found, we get one of our trigonometric identities, which is that tan theta is sine theta divided by cos theta. Okay, we're going to take a look at a little applet now. So if we are taking sine x, or we were talking about sine theta, rather than theta we're using x, we're going to look at what happens to the value of sine x as we increase the angle. So just to remind ourselves, sine theta was the y coordinate as we move around the circle. So as we move around the circle, the y coordinate, let's stop it there. When the angle is 0, the y coordinate is 0, and it increases. If you think about moving around this circle though, as it approaches the top of the circle, it's going to slow down. So let's continue there then. So it's going to slow down as we reach the top. It's going to reach a maximum of 1 because that was our radius, before it starts to decrease back down to 0. It will then go into the negatives. I'm going to stop here. So now we've gone past pi radians, or 180 degrees, and our y coordinate is now negative. It's going to go negative down to -1, and then obviously as we move round back towards completing the circle, it's going to increase up to 0 again. What will happen after we have finished our circle? As we get to 2 pi, or 360 degrees, what will happen as we continue? So as we continue, it's going to repeat this function. Okay, so this is going to become periodic. It's going to repeat. Every 2 pi radians, we're going to get the same wave. We can look at this with cosine as well. Remember, cosine was the x-coordinate. We think about where that's going to start. When our angle is 0, the x-coordinate is going to be 1, and it's going to get smaller as we approach pi by 2 radians. So let's take a look at that. It's going to start at 1. The x-coordinate is decreasing down to 0, and then it becomes negative as we approach pi radians, and then it starts getting larger again. It starts approaching 0. And of course, this is going to be periodic as well, and it's going to repeat this. Obviously, our sine and cosine graphs are very similar. Let's just take a look at both of them here. Okay, that's probably enough of them. You'll notice that they are really just a translation of each other. So you can see that the sine curve, the red line, is the green line translated across pi by 2.